Hello students, welcome to another tutorial on static equilibrium. In this video, we determine the mass m needed to keep a leg in static equilibrium, given the position of the center of gravity and also the position upon which this mass is going to be suspended. So here we are assuming that the pulley is frictionless, so that the tension in the string is all due to the weight of the mass m. So what we have to do, the first thing is to identify the forces that are acting on this leg. So we pick the hip joint as the pivot, since all the distances are given from here, and this only makes sense. It's the easiest point to work with. So remember the methods I outlined in the earlier videos on how to determine the pivot. It has to be one such that it makes the problem easy to work out. So I'm going to draw the system now as a line for easy manipulation. So let's take this to represent our system. It's a leg and cast. So let's say this is the point where the center of gravity is. What this means is this is where all the weight of the leg and cast tends to be concentrated. So this is just the weight of the leg and cast. So if we're going to calculate the weight of the leg and cast, the mass of the leg and cast is given as 15 kgs. So it's going to be 15 multiplied by 9.8. So this is what gives us the weight of the leg and cast. So what we're being told is that the distance from the hip joint, so let's take this, the point we're taking as our pivot. So this is the hip joint. So the distance from the hip joint to where the center of gravity is, it's given to us as that's 35 centimeters. So in meters, this is going to be 0.35 meters. So if we take the influence of the weight to be torque 2, so we're going to, since this again is clockwise, so this is going to, let's take it as torque 2. It doesn't really matter which one you say is a torque 1 and which one is a torque 2. So the only force which is acting on this apart from W, the weight, it's going to be that way, that force which is going upwards. So remember, it goes up, and then at the far end you have the weight of this object m. So in other words, the weight of m, which is m times g, is going to be equal to t. So when we sum the forces here, you guys should be able to see that the tension in this string is going to be equal to mg. So this is the tension that comes to act here. So this is going to be mg. So this is how we get that mg there. So for torque 2, this is going to be the weight, which is 15 by 9.8. This is the force. So again, observe that the two are already perpendicular, so there's no need for us to start getting components. So we have to multiply this with the distance, the perpendicular distance, which is 0.35. So if we do that, we get torque 2 as 51.45. Since this is torque, force is coming with newtons, the distance is coming with meters, so this is Newton meter. So the next thing is, what is torque 1? So torque 1 is the influence of the weight of the mass. So that is torque 1. So the weight is just mg. So the distance we're given is from the hip joint to where the force is attached. The distance is given as 78 centimeters. So that is going to be 0.78 in meters. So this distance is given as 0.78 in meters. So the torque then becomes the mass m, which we are trying to find, multiplying the gravity, which is 9.8, times, then the next thing is going to be the distance. Since here we're getting torque, the perpendicular distance is 0.78. Okay, so that is, let me just write that properly. So that is going to be times 0.78. Okay. So now from here, what we have to then observe is the formula we're going to use. So what we're looking at is
Since this is an equilibrium, the sum of the torques must be equal to 0. So now, which ones are the torques we're working with? So we have torque 1 and torque 2. So if we add torque 1 and then also add torque 2, they should give us 0. Now let's try to look at the direction. In which direction are these torques acting? So the pivot is this point, the hip joint. So let's look at each point in which direction is trying to rotate the leg here. So we observe that this is a downward force. So in other words, it's trying to rotate this system in this direction. So this is clockwise. And then if we look at the mass, which is causing the tension T here, which is mg. So what we notice is the rotation that we are causing here is an anti-clockwise rotation. So because of this, we can choose anti-clockwise to be positive and clockwise to be negative. So what we end up with is when we substitute, when we perform our substitution now, torque 1, remember that's the anti-clockwise one, so it's going to be positive. So what we had there was m multiplying, that was 9.8, multiplying the distance, which was 0.78. So from there, this is positive, but then the clockwise is going to be negative. So that is 51.45. So again, it is negative because it is clockwise. We're taking anti-clockwise to be positive and clockwise to be negative. So this is what equates to 0. So from here, what we get when we multiply this, we get 7.644. Then we have our m. So don't mistake the m to mean meters. The m here is for mass. This is what we're trying to find. So we move the 51.45, the other side becomes positive. So this becomes 51.45. So divide both sides by the coefficient of the m. We end up with m is equals to 51.45 divided by 7.644. And when we simplify this, we get the mass of the object as 6.73 to 3 significant figures. Okay, so since we use standard units throughout, the answer we get of mass is going to be in kgs. So this is how we get the mass. This was kind of a short calculation. So for our next video, we're going to look at another concept. It's application of static equilibria. So you guys can try this question out before we work it out together. So this is going to be for our next tutorial. So I always advise you guys to always try the question before checking out the recorded session, so that you don't really get to lag behind when we work it out, or just use the video as something to just help you polish up your methods. And as always, if you need any further clarity, you can always get in touch with me either through the comment section or get in touch with me directly using the email in the description. All right, we'll see you guys in the next tutorial. This was your tutor,